today we're downstairs doing some construction, some lab work, some building. Once again brought to you by Three Monkeys Solderless, home of the world's best cables for your pedal board, which is what we're going to kind of be working with today, some pedal board stuff, right? But great sounding cable. I got two kinds now. We have a high definition cable that's double insulated with a higher thread count, so to speak, of some special copper, as well as the standard. Both sound terrific. Easiest stuff to put together, both for your DC and for audio. And we've got a sale going on right now. So get to the site on the link below and get yourself some cables. Right, so here we go. So what are we going to work on today? Well, it's obviously we've got the new intro, so we're dealing with pedal boards and pedal board equipment and things of that nature, but as always related to the primary mission, primary directive of the tone. So a viewer and friend had seen a previous video that I had done with the 79 to 84 pedal board, which had just like a monstrous amount of pedals on it that were all Van Halen related from over the years. So it had, like, you know, the phasers, the flangers, the octave, the EQs, you know, the echoplexes, all that stuff on there. And then there was another set of switchers on there, one which would select loops, and another one which would actually was specifically related to these guys, right? The phaser and the flanger. And what I wanted when I built this sort of like pedal board was to make a or this, not pedal board, but this particular switching box, this particular loop box, was to make it momentary, which means that as you press on the button and hold it down, the effect is on for only the duration to which you hold it down. And when you release it, the effect is no longer in the loop. So for things like Unchained or Ain't Talking About Love, you don't have to do the double tap. You just hold it down, and when you release, it's gone. Hold it, release, hold it, release. Same thing for the phaser. So if you wanted to get in and out quickly without a double tap, which kind of messes me up, because I'm one of those guys that can't rub their tummy and head at the same time. So yeah, it worked out really well, and he saw it and was like, can you make me something like that? And I was like, definitely. So we're going to build one now, right? We're going to take some time and we're going to build it. So I'm going to place these guys off to the side here, right? And then we're going to bring in some of the things that we're going to use. Obviously, we're going to use a lot of pink drink, right? As always. But we'll start off with the box, right? And here it is, right? This is a looper box. I think I got this one from Love My Switches, which is out in Seattle. I buy a lot of stuff from them. They're pretty cool. So they got some interesting stuff that a lot of places don't have. Like, for instance, I mean, you can get these pretty much in a lot of different places, but they've got them as well. The barefoot buttons, right, which are the big diameter buttons. They had sent us some Three Monkeys labeled buttons a while ago. I thought those were really cool, but I really enjoy these because it makes it a lot easier to play, to work with, and it's a bigger target, and they look cool. So we got the black box with the anodized red barefoot buttons there, right? We're going to be using a bunch of switches, lamps and such. Right, so we'll have a little indicator lamp because this is going to be powered. Our switches, or rather our jacks, right? Switchcraft jacks. And we've got our Momentary, right? Momentary double pole, double throw toggles, right? Or push buttons. You don't need to use the double pole, double throws at all, the way I'm doing it. But these ones happen to have a very good construction and are very durable. So I'll forego, you know, I'm only going to be using 2 terminals out of, you know, the 9 here, you know. It might seem like a waste, but I think it's just a much more rugged construction, so I'm willing to you know, go a little bit further. The reason why it's powered is that I found the best way is not to use the switching capability, right? Because there's an in-between spot where it gets a little weird. But use this rather to switch some relays, right? So we have some relays here, which we're going to use. So this basically is just going to be bringing the power to the relays, right? And the relays will take care of all the switching of this signal, okay? And then also, the reason why it's powered is that we're going to be putting in a buffer, right? So we've got a circuit card with a JFET buffer on there, and that's really important if you're using like the Phase 90. The Phase 90 works so much better when it has a buffer in front of it, something to drive it a little harder. It gets a lot quieter. The effect to my ear sounds a lot better. Same thing with the Phase 90. So we're going to put a buffer in this unit. It won't affect anything, you know, if you're using it in different situations where you might have other buffers. I was doing some thinking about putting a bypass switch on this unit, but then I kind of, you know, put my thinking cap on a little tighter. I was like, you know what, that's not needed at all. In fact, it could be detrimental. So no bypass switch. We're just going to have the buffer going straight through there. So put this, well, let's open it, right? Let's see. Yeah, that looks nice. It's a nice flat black powder coat. So put this down. Got our screws in there. Aluminum. Nice. Okay, I'll reserve that over to the side. And we'll begin to do the layout, right? Because it's always a good idea to plan and work out your boards or your projects before you go ahead and start drilling, so you don't end up with a bunch of extra holes or goofy stuff or missing things and rework. So we don't like to do that. I mean, a lot of times I'll just do it off the top of my head. You know, I don't know, I'm good at that for some reason. That I'm good at. There's a lot of things I'm not good at, which are probably because I'm good at this. All right, anyway, so we're going to do a little footprint of the box, and then we'll start adding components in there and figure out spacings and all that kind of stuff. So we'll do a little outline of it, all right, and we'll show you how this is all going to kind of work as well. When we're actually getting around to cutting onto the box, we'll put tape on it to protect the finish, as well as allow us to draw our marks for where we want to drill holes and things like that. All right, so let's start off. We're going to need 2 relays, one for each loop, right? One for the loop for the Phase 90, and one for the loop of the flanger, right? So we're going to put these down. We'll put the buffer in. Right, here's the buffer. And these have little holes in them, so we can mount them on a standoff on the inside of the chassis, right? And then we're going to have these guys, right? So let's open up our bag of switchcrafts. And these are stereo, so not stereo rather, but switching jacks. So they have 3 terminals on there, right? And they have this little tab there, right? And then when something's plugged into it, it breaks this connection, which is related to these terminals. So this is good to use for automatic switching if there's nothing in the loop, right? So if you don't have things plugged into there, it'll just kind of fire the signal or whatever's on there to the next switch. So it'll sort of close the loop, so to speak. So we're going to have an input and output, ascend and return, right? So actually this is upside down. So we're going to put, we'll leave them like this. So that's the way that's going to be. This is upside down. So we have one jack there. That's the input. This side will be the output. Because remember, we're flipping it over, right? This is the bottom, so to speak, right? Let me show you. So I would assume that everybody that has these things, right? This side would be input. That side would be output, right? So when we tilt it over and flip it around, this will be the input side, right? That'll be the output side, and these will be the sends and returns, right? So you see what I'm sort of getting at? Okay. That's confusing for me. being kind of dyslexic. So yeah, let's keep going. Let's keep going. So we got the two here, input outputs, right? And we got these two guys here, right? We got this guy here. So that looks good. And I think we can put the jack for the DC entrance there. And we've got one of these little guys. These are Lumberg jacks, just like our favorite boss, Mr. Lumberg. Pull this out of here. All right, so they have a really kind of cool look to them, kind of small, not a big footprint to them. So I like using these things. All right, so we'll close this off, or rather put this nut on, and we'll put this over here. All right, actually this will go like here. All right, now we have another interesting development, so to speak, in this, in that the relays I like to use are these 5-volt. These 5-volt relays, and the buffer board works on 9. Right, so we're going to need a way to bring these relays to 5-volt while we still have the buffer operating at 9 volts, right? So to do that, we're just going to use the simplest method. I mean, there's a few ways you could do it. You could use like diodes, like Zehners, and clamp the voltage. I'm just going to use a regulator because I like regulators because they're fun. So that's a regulator. And what a regulator does is it takes an input voltage that is higher than the voltage that you're looking to drop down to, and it does it on its own, right? And has three, it's very simple, has three legs to it coming out of the case. One is your input, the next is your ground, the middle is the ground, and then the one next to it is your output, which will have the 5 volts on it. Now, I think I got that right. I might have get things backwards here and again, but I think that's correct. So we'll put that, let's say that goes here, and we're going to need a terminal, right? So I'm going to need a terminal strip. I think I have one here somewhere in my piles and piles of stuff. Yeah, here we go. So we're going to use, I like these little guys, right? We'll use one of these terminal strips, and we'll cut it down to size and mount the voltage regulator on it, right? So we'll use the middle 3, so that'll go there. Let me get my pair of cutters, and I will cut off the excess, right? These are actually fret end nippers, or fret pullers too, for doing guitar work, which I like to do. I build a lot of guitars, not as much anymore, but I've built all kinds of guitars, Les Pauls and Explorers and SGs, and you've seen all the Stratocasters and original designs, and it's a lot of fun. So anyway, this will go here. Right, this can go here. Okay, and then we have these little switches, which are not so little. So we'll put these, we can put one like right here, right? And we could put one like right here. So I think when we actually do the cutting, we'll probably put these two in as the keystones first, right? Because we'll want these equally spaced and centered, and then we can kind of determine where these boards go inside, like so, after we have these in place. So that should be good. But we're going to do a little bit of a diagram here that we can work off of for how we're going to, you know, wire this whole thing up. And we can, oh, we also have this, I think we should use this. I think this is always good to have. Right, we got an indicator light, right, LED. And I like this one, right? It's kind of cool. It's got the case already built on it, so it's not like the press-in plastic ones that I don't like as much. So this will go probably like, let's say like right there, right next to the input of the DC. So when you plug it in, you know you have power. Okay, so let's begin. Take a shot of pink drink. So let's begin actually drawing into these. Let me get a box or something to put this stuff in. Here's a box so I don't lose anything. We'll just put all our parts that we're going to use in this box so we don't lose stuff. I'm good like that for losing stuff. Okay, we don't need this box cutter right now. These little guys in here. Okay, put this on the table. So we'll start with just, this will be like the wiring schematic. Okay, so we'll start by drawing in the different components. So this is the buffer board, right? And it's the little guy there. This is going to be there and there. Something like that. We don't have to really get this alignment correct, because like I said, we're going to base everything off of the location of those actual switches, right? And then we'll fit these in afterwards. But this is at least a good sort of idea of where they'll be located. And then just going to draw, because my pen won't fit through that. I'm going to use a mechanical pencil to draw in the different points here for the relays, right? Which makes it kind of handy. And we'll be using the mechanical pencil for drawing in our wiring as well. So when we make mistakes, we can use the eraser. I'm sure there'll be a mistake, and by the end of this, it's going to look like a spaghetti factory. But, you know, if you're trying to build something like this anyway, I'm guessing you'll be able to follow along enough and be able to work it all out. So I'm going to change these from pencil to pen real quick. Missed one. That happens. So these boards here actually hold the relay, as well as a diode, which would be a polarity, a protective diode. It also helps the relay work a little bit better. Missed one there too. Okay, and then on this board we have a few points that we have to observe. One would be here, which is the output, and this would be the ground for the unit for the power supply. And then we have an input here, and then we have right about here is the positive, right? So we'll put positive, this is negative, this is output, and this is input. Okay. Now on this we have the power supply ins, right? And here we have a diode, right? And that would be the direction of the diode. It's just a, you know, a silicon. I think I usually use a 4001 diode there. Band facing that direction, right? So you get the polarity correct. And then the relay is actually sitting right here. The box would be in this area here, and then I have these little guys sort of legged out to terminals on the edge. So that's where I'm going to be putting my connections for the inputs and outputs to do the actual looping of the signal to the jacks. All right, so we had an input jack here, right? And then we have our output jack here, right? And these, we would have another jack here, and another jack here, and a jack here, right? And a jack here. And then over here we would have the DC in, and then we would have our lamp. All right, so we'll make it look like the sun. All right, so these jacks each have 3 terminals on them. One's ground, one is switched, and one is not switched. So you have ground, switching, unswitched. Okay, that's how these jacks work in this orientation that I'm seeing them in my brain, so to speak. Alright, so then we're going to bring out to here. We'll have this side and this side. And we have this side and this side. Okay, so we're going to make this one's positive, this one's negative. Right, so we'll have a positive and a negative attached to the lamp. So as soon as you plug in power, your lamp will go on. Okay, then we're going to have our input jack. Let's start with the voltage regulator, right? And over here is our switch. I didn't even finish putting in everything that I needed to put in. Okay, so this is the switch, and we're just going to mark 2 of the 9 terminals that we're only going to use 2 just to keep things clean. So this is our little solder tab, and this would be a that's our regulator, right? Okay, now so this is the output, right? So this we're going to do out, and this is the input, and this is the ground, right? All right, so we're going to take a line off our DC jack, positive to positive, and there would be our output. So we're going to bring the output to the switches, right? So we'll have this going over to our switch here, and we'll have this going over to our switch here, and then to the right. So yeah, this is top is positive on my relay, and bottom is negative. So this would go here, as well as this going to here. Now we're going to bring in the grounds, right? So the grounds come from here, and they would go to there, as well as there. All right, so you can see we've got the relay's negative connection is connected directly to the ground on the regulator, right? And then the positive is going through the switch, each one, to the individual relays, right? And so when you press the switch, it makes the contact, powers the relay, which then opens and closes the contacts in there, which will do the switching to the jacks. All right, so we're just gonna notate that this is the positive, so that will go to the DC in, and as well as that will also go to the DC in, which would be negative to negative, positive to positive. As soon as you plug it in, this guy's ready to go. If you wanted to do as well, you could put a diode before the positive, or just across here, so that way if there's a reversed polarity, or you can make a little bridge, you could protect it, but I don't think that would be necessary. Let's see. All right, so let's begin bringing stuff in. So we have our input from our jack going to the input of the buffer. Okay, so the output of the buffer is going to go to the relay. Okay, so this I believe is the common, right? So it's going to there. And then charged, I believe, is this position here. So this one should go to the send. Now I wanted to show you this here. So this is the send for this one, which may seem backwards, right? Because when we turn this thing over, right, boom, then you have the return on this side. But as you can see on the good old phase 90, they're sort of backwards. All right, so when you would lay this down next to your switching box, you would have the input closer to the center of the box, right? And the output closer to the edge. So this is made for a flanger, just for this eddy thing. So instead of crossing the wires, we're just going to do it here. So this is going to be the send, and this will be the flanger side, right? And this will be the return. Okay? All right, so now the return is going to head over to the other side, right, which we'll bring over. Let's bring it from here. Okay, and then our two switches on our jacks will connect center to center, so that if nothing is plugged into the flanger, you'll have a continuity of signal continuing through there. So if you just had your phaser that day, you could still use the box without having to put a cable in between, right? So that's a good idea. The next wire that we're going to have to put in is, we're going to continue now from the relay to the next, right? So we're going to go from this right here to this right here. So should we go this way? So it's kind of a mess in here. Okay, so that works. And then this guy right here is going to go up to, on this case, this one's going to be the send, and this one's going to be the return, right? Because on this we have input on this side, which is be closer to the center of the box, right, when it's flipped over, and output will be here, closer to the output of the box itself. So let's do the same thing again. So the send is going to come right to here, and the return is going to come over to here, right, because that's the other side. And then we'll kind of flip this over, right, and then this guy here, you know what, actually this is not correct. Move this out of the way. This has got to go to here. Okay, so it has to go to the switching side of the relay, not the common terminal. The common terminal needs to go to the output, or this won't work, right? So if there's no switches, if you're not putting anything into the loop, it has a straight path, right? Oh, we have to connect these. Okay, so that should work. So let's think about this in terms of each operation. No effect selected. So input going into the buffer, output of the buffer going to the common terminal, which is now switched to here, right? Because it'll either go to this one or this one will go to this one, right? So it's the 1 to 2 or 1 to 3. So in this case it'll be 1 to 3, which will flip us over to here, which will connect us to here. So this one might be backwards too. No, that's correct, because it would go to here. So it would be this one to this one, which would be connected here to here, which come to here, which would be to here, to here, to here, to out. Okay, so that's correct. All right, so one more time, because I know it's hard to follow what I'm saying. So input jack into the buffer, output into terminal 1. 1 is connected to 3. 3 is jumped over to the other side of the relay. 3 is connected to 1 again, comes over to the next relay, 1 to 3, 1 to 3, jumped over to 3 on the next terminal, back to 1 and out. All right, so we have a straight path if nothing is connected. Now if it is selected, it's going to go input jack to the in of the buffer, output of the buffer to here. It's going to be 1 to 2 this time, right? So common to number 2. 2 goes to the send and return. Return is going to come back to here, 1 to 2, and it's going to come back to here. If nothing is selected here, it'll be 1 to 3, cross 1 to 3 and out, so that works. If something is selected, it'd be 1 to 2 going to the send, and the return would be 1 to 2, return going to output. So this is correct. So this is exactly what we want to have. Now in terms of the buffer here, or rather, excuse me, the voltage regulator, there is, I didn't want to put it in there because it's kind of, it's going to muddy things up. But this is basically the additional parts that you kind of need for the regulator. All right, so that's the 5-volt regulator. Between these, you're going to have 2 capacitors. I usually like to use a 47 and a 10 mic, right? And these would be, 10 volt, 20 volt, whatever you can get, small ones, and those will help with stabilizing the regulator itself, as well as removing any switching noises, right? So the good thing is you don't really have to worry about switching noise when it's powering relays. If you were going to power, well, if you're building a power supply that you can use to, power effects pedals, with power JFETs or ICs that are amplifying signals, your guitar signal, you're going to want very clean, DC power. And if you're not using a wool wart, let's say you're making your own, which I've done, you make your own power brick, then these regulators, making them silent switching wise, is a great idea. And you can even use some tantalum capacitors as well in tandem with the whatchamacallits, with the God, I'm losing my mind, with the aluminum axial electrolytic capacitors, and it helps quiet them down even more. So we're not going to need those for this project. All right, so I think that's done. We know what we want to see. So the next thing to do would be, I guess, to just kind of, how are we on time? 30 minutes, wow. All right, next thing we would want to do is put some tape on this, right? And I'm always a fan of taping up the box. It helps protect it against all kinds of tragedy, where you might scuff it with something you don't want to scuff it with, right? And then you can draw on your box, right? And mark everything where you want it. And then drill through the tape, and you'll have yourself a nice sort of job. So fold the tape over, get some more tape. Be interesting to know, well, not to know, but there's kind of like, we're going to do this too, very shortly, right? Because I actually have done a couple of things. I'll show it to you right now while we're doing it. So we got like this script Phase 90. It's a new one, right? It's okay. It sounds pretty cool. I have the one that I bought when I was in high school, right back in about 400,000 years ago. It's a 70s model, but it does have the original script circuit card in it with the script ICs. It does have the resistor that was not there for the script mods. It's the later one, but I think that mod doesn't do a whole lot. But interestingly enough, anyway, I always think that his phaser, I think we were talking about this in some other videos. His phaser did a few things that I haven't found my MXRs ever to really do, and I've played around with them a bunch, and I've found some useful things for him. So what I'm thinking about doing, right, is I think maybe this one, right? Well, I don't know which one to molest. because this one's been molested quite a bit too, right? I had to replace the trim pot in it. You know, I put in a DC, you know, input jack on it, and a rehouse isn't that bad of a thing to do. I don't know which one to do it to, but I did get out the pumpkin orange paint and make myself a pumpkin orange trapezoidal box, right? Where I wanted to put in, rehouse the Phase 90 with a few mods. Like, for instance, one that would bypass a couple of stages of JFETs, or one that might change the way that the low frequency oscillator hits two of the JFETs, and so they're still sort of amplifying. Maybe change the feedback resistor around the ICs as well. Have a switch for that to make them boost as opposed to be unity. Have a blend control in there. Have some, you know, a depth control. There's a lot of mods that are out there. So I've decided that I wanted to, you know, make a bigger one that had a whole bunch of different switches on them, and then experiment with that and see, you know, what I like, what's going to work out. So in another video, I think we're going to rehouse. Maybe we'll rehouse this, but this is, you know, you could buy these, and it still has the same kind of board in them as that one, a reissue board in them. And I won't have to destroy the Phase 90 that I've had since I was, you know, whatever, 17. Okay, back to what we're talking about. All right, so we have the input on this side, output on this side, jacks up here. All right, so let's grab some ruling equipment. All right, so we have this ruler and this ruler. All right, so I'm thinking we'll put the jacks maybe a little bit closer to the top. All right, so they sit low to the ground, but also give us room inside there to mount stuff. So we'll get an idea of like where we want the jacks to be. That's like a good place. I grab this so I can measure. All right, let's say at 1.25 inches from this side, we'll put our line. I wish I could turn on the lamp, but it screws the camera up. It may seem like it's bright in here, but it really isn't. This zoom camera seems to like low light a lot better. It seems a lot of these digital cameras seem to like low light. It's like my iPhone always seemed to do better in a low light situation. Like the colors were a little bit better, it got a little less grainy. But then again, in some other cases, like the upstairs, in the camera up in the submarine studio, that one likes a lot of light. It gets really grainy unless you're just bombed with light. So I have 2 work lights up there, and they get kind of hot to work underneath. Yeah, that looks good. All right, and then we'll do the same over here. All right, so get the and we'll find the middle right there. Good. Do the same thing on this side. So a good trick for finding the middle of something is to just take a whole number on your ruler and sort of guesstimate where the middle is, and then look at the two sides and get those to where they're at the same number away or the same distance away from the next one. So I got a 3 in the middle, a 2 and a 4 on the side. So I just move it until I see a 1/4 inch on either side of the 2 and the 4 until I hit the edge of the box. All right, and then there we go. I know where the middle is. And there we go. There's the middle. All right, so for these ones, let's say we put them, let's start with like 1.5 inches. I think might be right. So let's start with that right there. Let me grab another couple of these guys. All right, so we would go here. Let's just get the middle of this box first. Okay, so that's the middle. All right, so we can just test that. 5 inches. Yep, okay, so that's the middle. So right here will be the DC. Right, DC in. And then we're just going to need to put 2 of these on this side and 2 on that side. So let's see if we do it. How do we want it to look? Like that, 1.5 inches, 3. Yeah, I think that'll work. So we'll just start here. So we go 1.5 inches for this one. Turn this around. 1.5 inches on this side. And we'll go, say, 2 inches. Okay, so this would be, right, because we're orientating it this way. So this one's going to be the return, this is the send, and this one's the send, and this one's the return, and this is the flange, this is the 90. Okay. So that's all that stuff. Then we're going to need to put in the switches, right? So orientated this way. Let's get our switches. All right, so once again, we'll get the middle of the box. So let's start. I'm going to find my center line. All right, that's our center line. Look at this. Maybe we'll put him. I think that might be a good place. No, actually, we need to just make sure that we can fit one of these in. All right. And this will kind of be here, right? And this one will kind of be like that, so to speak. So So let's say 3 inches, I think is correct. So 3 inches from each end. Okay. Let's just see once more. Let's get a shoe. Maybe we should go. Let's cheat it 1/4 inch back in. Right, so we'll go here. And here. Oh yeah. Yeah, even if you're wearing your Doc Martens, I think you should be able to squeeze your tootsies between those two guys. All right, so let's see. I think that's it. So I think now I'm gonna drill these out on the drill press downstairs. So I think that's good for right now, and I'll be right back up with the box all drilled up.